Hello, everyone. Today we're going to be talking about the second part of Lesson 1.6, Precision and Measurement, which is about calculating with significant digits. There are some specific rules that we'll need to talk about in order to determine how we need to round using significant digits, whether we're adding and subtracting or multiplying and dividing. So when you perform calculations involving measurements, the number of significant digits that you write in your result depends on the number of significant digits in the given measurement. So if the problem ever asks you to round using the correct number of significant digits, you have to look to the numbers that you were originally given in the problem. So there are two different rules. First, we'll look at addition and subtraction. So this rule states that you need to round the sum or difference, so just an addition or subtraction problem, to the same place as the last significant digit of the least precise measurement. So I know that's a mouthful, but the key phrases to note here are the last significant digit, so the place value. So adding and subtracting is all about place value. That's going to be important in differentiating, adding and subtracting from multiplying and dividing of the least precise measurement. We look at the one that's the least precise because we don't want to provide any more confidence than the least precise measurement gives. So let's look at an example. Let's look at 3.24 plus 7.3. So let's add those two together. So first of all, which one of these numbers is least precise? So this second one would be least precise. And then based on this number, maybe let's highlight it. So we know that this is the number that we are going to use to determine how to round to. Since this number goes to the tenths place, that means we're going to round our answer to the nearest tenths. So the place value of this least precise number. So I'm just going to make a note here that we need to round our final answer to the nearest tenth. All right, so let's go ahead and add. So this would be 4, 5, and then 3 plus 7 is 10. So we get 10.54. So we need to round to the nearest tenth. So the 4 doesn't round it up, so it becomes 10.5. I'm going to do this little squiggle sign that means approximately 10.5 using the correct number of significant digits. All right, and then the second rule is multiplication and division. So it's similar in that it uses the least precise measurement. However, you're no longer looking at the place value of that least precise measurement, but the number of significant digits. So and I'm going to use SD to represent significant digits. So adding and subtracting is based on place value. Multiplication and division is based on the number of significant digits, not necessarily place value. So let's look at an example here. So let's say 40 and then times 31. So first of all, which one would be least precise? The 40 would, since it only goes to the tens place. So I'm going to highlight 40. This is the number that we're going to use to determine how many significant digits our final answer will be. So it says it has to have the same number of significant digits as 40. Well, how many significant digits does 40 have? It has one significant digit. So that means our final answer is going to have one significant digit. Okay, so let's multiply these. This would be 0, 4. You can use a calculator if you want. So 1,240. So this problem is a little weird and you might question it because we're saying that this needs to round so that it has one significant digit. Well, that means that the 1 is going to be the only number that we could have. So it's actually going to round to 1,000. That way it can only have one significant digit. Right now this number has 3 significant digits, and we have to round it so that it has 1. So this might seem a little odd, but remember, it's just based on the least precise measurement. We don't want to give a measurement that's any more precise than the least precise, because we don't want to give any more confidence than this measurement gives. So now we're going to do some examples with calculating with significant digits. All right, so part A. So go ahead and if you add this in your calculator, you'll get 64.55. And then centimeters adds to centimeters. Okay, but now let's think about how we'll need to round. Well, this is adding and subtracting. And the rule for that, going back here, says based on the least precise measurement, you go by the place value. So the place value as the last significant digit of the least precise measurement. Okay, so which one would be least precise? The first one, because it only goes to the tens place. And what's the place value? Well, we just set at the tens place. So this will be rounded to 64.6 centimeters. All right, part B. 6.4 feet times 2.15 feet. So first of all, when you just type this in your calculator, the answer comes out to be 13.76. Now let's talk about the units for a minute. If you multiply feet times feet, it's kind of like length times width. And the unit you get if you do length times width is an area. So any unit that you're going to have when you're doing multiplication is going to be units squared. So this is going to be feet squared, like you're calculating the area, like square feet. So we have to look at which one is least precise, and then since it's multiplication, we consider the number of significant digits of that least precise measurement. So first of all, 6.4 is going to be least precise. 6.4 has 2 significant digits. So we want to round 13.76 so that it has 2 significant digits, which would end up being 14 feet squared. All right, part C, 27.23 meters minus 12.7 meters. So this is just like the part A's rule. So if you subtract this in your calculator, you would get 14.53 meters. And the first you ask which of these numbers is least precise, and the 12.7 is. And then based on this, you say, what's the decimal point, or what place value? And that would be the tenths place. So we want to round our answer to the nearest tenths place. So this would be 14.5 meters. And part D, 45.16 yard squared divided by 4.25 yard. Now let's talk about the units here. So with multiplication and division, the units are a little different. So we have yards squared, and then think about division as like over yards. Well, if you have yards squared divided by yard, then one of these yards will cancel with one of these yards, and you'll actually just end up with yards. So if you ever are dividing, the first unit is going to be yard squared, the second unit will just be yard, and your final answer will just have yards in it. So if you divide these two numbers, you get 10.62 in the calculator. Now let's consider the rounding. So which one of these would be least precise? So actually they're both they both have the same level of precision, since they both have the same units, technically we're just in yards, and they both go to the same place value of the hundredths place. So if they both have the same level of precision, then you just go by which one has the least number of significant digits, and that would be this one. So this has 3 significant digits, so we round our answer to 3 significant digits, which would be 10.6 yards. All right, you're going to get much more practice in the 1.6b Edulastic assignment. But for now, thanks for watching.